Hi everyone and welcome to God on Fire. This tutorial is the first part of a series in which we will delve into the creation, use and management of spawners within a game scene. Spawners are responsible for introducing new elements into the game scene, which could be collectibles, characters and so on, during the game. Therefore, to understand what they are and how they work, let's create one. So, let's go to Content, right-click, Blueprint class and choose an actor class that we will simply call Spawner. Double-click, go to the event graph. Our spawner, in this case, will begin its execution as soon as the game starts. So, from the event begin play, look for the spawn actor from class. This node needs some information and resources to work. In class, we should insert the class we want to spawn into the game scene and also provide the information about the spawner's position. So, look for get word transform. Default scene root as the target component, which is the spawner's default scene root. We'll see in other tutorials how to give other types of references and why. Now, let's create a class to insert into our spawner. So, Content, right-click again, Blueprint, and choose an actor class that we will simply call Object. Double-click, put a simple sphere inside it, go to the Simulate Physics section and check it. Compile, save, go back to the spawner, insert the object class inside, compile, save. Return to the game scene, place the spawner inside and go to play. As we can see, our sphere will be spawned. Now, let's delve into the behavior of our spawner. Here we have the part dedicated to collisions. The default setting refers to the setting that the spawned assets have, or it takes into account our project's settings. However, we have other choices. One option is always spawn, ignore collisions. Let's select it to activate it. To see how the settings work, add a cube to the scene and place it above our spawner. So when our sphere is spawned, it will collide with it. Now, also activate Simulate Physics on the cube by checking it. Go to play and the sphere, although colliding with the cube, will be spawned. Now return to the spawner. Let's look at try to adjust location but always spawn. This means that when our sphere is spawned, it will try to adjust its position, but in any case, it will always be spawned, even if it can't avoid the collision. Go to play and test, and we can see that our sphere is spawned. Now, let's change the setting to try to adjust location, but don't spawn if it's still colliding. This means that it will try to adjust the position of the spawned asset, but if it can't avoid collision, the sphere, in this case, will not be spawned. So let's go to play, and as we can see, the cube falls to the ground, and our sphere is not spawned. Return to the spawner again. Let's look at don't spawn. In this case, it will not even try to adjust the position of the spawned asset, but if a collision occurs, the object will simply not be spawned. Therefore, going to play, we can see that this is exactly what happens. Let's return to the spawner, choose this setting, try to adjust the location, but always spawn and continue. Now, as we have seen, once the game starts, the sphere is spawned only once. Obviously, we may need to spawn the same type of asset multiple times during the game. Therefore, we need to use a loop, specifically a for loop, flow control. Now, by putting our for loop inside, we immediately notice that it has a first index and a last index, which in this case have the same value. So, if we spawn right now and go to play, only one sphere will be spawned because there is only one reference index, index 0. However, if we change the last index to, for example, 2, we will have 3 indices. Now, the indices don't not indicate quantity, but rather a position. So this means that first what is at index 0 will be spawned, then at index 1, and finally at index 2, thus spawning 3 spheres. Compile, save, go to play, and here are our 3 spheres in the game scene. As we can easily observe, our spheres are spawned one after the other. Obviously, we will also need a delay between each cycle. For example, to spawn characters every, say, 30 seconds or every minute. To do this, we need to modify the for loop and create our own macro. By double-clicking on the for loop, we can see how it is implemented. We have the input, the output, the condition under which the cycles are executed, deemed true as long as the running loop index is less than or equal to the last index value. Here we have the increment, which means that with each cycle, our index will increase by 1. We can also change this behavior, setting a step value for example, 2, 3, and so on. Once this condition is false, it will go to the false branch, thus ending the loop. To add a delay, we need to go to Content, right-click, Blueprint macro library, click on it and choose an actor class. We will rename it as for loop delay. Let's go inside it, double click with the left mouse button. As we can see, we simply have an input and an output. Now let's go to the for loop macro, copy all these nodes with Ctrl C, go back to the for loop delay, Ctrl V, and paste everything. Now we need to add parameters to the input and output, just like in the default for loop, and also add our delay to obtain a delay between each cycle. So, in the input, we add an integer parameter, our first index, then the last index also as an integer, and finally our delay, which in this case will be of type float. In the output, we will add an exec parameter, which we will call loop body. Now add the index, which must be of type integer, and finally the completed, which will also be of type exec. Now let's connect everything. However, in the input, I forgot to insert a parameter of type exec, so let's add it and call it simply exec. Let's change the parameter type in this section, click with the left mouse button, hold it and drag the parameter up to give a better order to everything. We need to connect everything correctly, as we were saying. So let's insert the first index here. The last index, of course, must go in the condition, thus on this pin. Finally, we need to add the delay between each cycle, which will be inserted here, where a new cycle starts. Therefore, pull the connection, look for a delay, insert the function, and of course, from the delay parameter we inserted in the input, connect it to the duration of the delay function. Let's connect the local integer variable to the index of the output, the false of a branch to the completed of the output, and finally rename the macro in this part. Save it, return to the spawner, right click, for loop, here it is, insert it and connect everything. Let's insert a value of 2 in the last index and increase the delay between each cycle. For example, set it to 3 seconds. Now, compile, save, return to the game scene, go to play. A sphere will spawn first, then another sphere, and finally another sphere, 3 seconds apart from each other. Now we have a constant delay here, meaning a sphere will spawn every 3 seconds, but we might need to spawn our asset with a random frequency. So let's pull the connection, check the context-sensitive box again, look for in-range float, and set a delay within a minimum of 1 second and a maximum of 20 seconds to better see the random behavior during the execution of the cycles. Compile, save, return to the game scene, go to play, first sphere, second sphere, which will spawn with a random delay, and finally the third sphere, which will also spawn with a random delay within the values set in range. Now we have seen how to spawn a static mesh. Let's now see how to spawn an NPC, a non-playable character, thus a character controlled by AI, and make it work within the game scene. Now, this is not a tutorial dedicated to using artificial intelligence, but we will see how to quickly create an NPC, because we will need it later in our series of tutorials to experiment on it with different functionalities concerning spawners. There will also be a tutorial dedicated to AI, so subscribe to the channel. Let's start by going to the blueprint of third person, duplicating it and renaming it as BP underscore enemy. Now return to content. To make everything work, we will need a controller. So right click, blueprint, look for AI controller, select it and rename it as AI underscore controller. We will also need a behavior tree, so left click, go to the artificial intelligence section, behavior tree, and rename it as BT underscore enemy. Open our behavior tree. Here we will insert all the tasks that our NPC will have to perform and set how these tasks should be carried out. To make everything work, we will also need a blackboard. Create it by going to new blackboard and rename it as BB underscore enemy. Find the blackboard here or in content. Open it. As we can see, we already have a key created. Delete it and create a new key of type object and rename it as target. This key must be associated with a value that will allow the AI to understand how to perform the tasks we will insert in the behavior tree. Therefore, with our key selected, go here to key type and insert the third person character in this part, because in this case we want the NPC once spawned to come towards us and continue to follow us. To do this, go to our behavior tree. From the root, add a sequence that will allow us to execute and order our tasks. From the sequence, pull the connection and insert a task that is ready by default, which is move to, like this. Here we find the blackboard key. Since we have only one key in the blackboard at this moment, our target key is already inserted. If we had more keys in the blackboard, we would have had to select the one we are interested in. Thanks to the association of the target key with the move tool, the AI will understand that it must move the NPC toward the BP third person character, our character. Now we need to go into the AI controller and make everything start. To do this, search for another event node, which will be the event on process. Connect everything to another node, which is the run behavior tree. This way, our controller will execute the behavior tree we created. We will need to insert it into the BT asset. Now, continue by inserting a set value as. As we can see, removing the context sensitive check, there are several alternatives. What we are interested in is set value as object, because the key we insert into the blackboard is an object type. The target will always be the blackboard, so look for it and insert it. Get AI variables and get blackboard. In the key name, insert the name we assigned to the object key, and we can insert it through a node. For example, the make literal name. We can also do it differently, but for the moment this will do. Write exactly target as it is written in the blackboard. Here we simply need to give it the object's value, so we can connect the get player character. Now we have set everything up. The last step, we need to put a delay at the start of this event, because the event on possess is a type of event that is executed even before the game starts. So with a slight delay we can make it work. A delay of just 0.2 seconds will do. So compile, save. Now, for our NPC to work, we need a nav mesh, which we place in this part. Press R, increase its size, scale it to cover the entire scene. By simply pressing P, we can see where the NPC can move on the green surfaces. Return to the BP enemy, double click, go to the control part and insert the controller we just created, which is the AI underscore controller. Compile, save, place the BP enemy in the game scene. Also remove the camera because we will not need it. Compile, save, return to the game scene and go to play. As we can see, the character moves toward us and continues to follow us. Now, if we want to spawn the character instead of placing it in the scene, we can insert it into our spawner. Let's insert the BP enemy into the spawner, compile and save, return to the game scene. As we can see, by going to play, our NPC is spawned, but does not come toward us. This is because the controller does not take the possession of it. To make this happen, we can return to the BP enemy, look for the setting within the blueprint auto poses AI, and see that it is set to placed in world, meaning that the AI will take control of our NPC only if we place it in the scene. If we look at other settings, we can make the AI take possession of our NPC also when it is spawned or in both cases. Choose the latter option, compile and save, return to the game scene, go to play, and this time the NPC, once spawned, will be controlled by the AI. Now, this is one solution we can adopt. Another solution is to use a different node. So let's search for spawn AI from class. This node will allow us to simply insert the BP enemy, our NPC class, to make it work correctly. Also, insert the behavior tree, BT enemy in this part. In the location, insert the get actor location, compile and save. Return to the BP enemy, set it once again as placed in Word, but in this case, using the spawn AI from class, the NPC will still be controlled by the AI. Go to play and see that everything works as expected. Now let's see how to spawn special effects created through a particle system. To do this, search for spawn emitter at location. Always give the get actor location, like this. In the emitter template, insert an explosion, for example. So every time a cycle is activated, an NPC will be spawned along with the particle effect. Compile, save, go to play. As we can see, this is exactly what happens. For now, that's all. Thank you for your attention and don't miss the upcoming tutorials in this series. Subscribe to the channel. See you next time.